Okay, question 8. So we've got transfer thermal energy, and it says calculate the rate of increase in temperature at a time of 150 seconds. So you'd have to go up. This is spacing my eyes out already. There, and then the crucial part is if I want the rate at that point, like you do in chemistry for rates of reaction, draw a tangent to the line. It doesn't matter whether you pick a small triangle or a big triangle. I'd pick a bigger one because it'll reduce the error that you make in your measurements, but it's draw a tangent. So I'll get rid of my rough line there, and you can see there's a better tangent, and then I'm going to do the 110 minus 145. So you can see I've taken that change there is at 110 to wherever I picked it. It would have gone to around here somewhere, but you can see what I'm doing. I'm just measuring whatever that change is divided by this change here. All right, so mine would have, my actual line that I used on my piece of paper, I can't really do it very well on a screen. I'd have drawn a really big line and got a really decent line like this. It's meant to be a decent line. Sorry, that's not a decent line. But you know what's going on. And you know, if you've got it right, if you get an answer in that range. So 0.33 plus or minus 0.7 they allow you. Next one, the kettle's got an efficiency. So we've learned efficient, useful tools. This is useful output. This is total input. I've also taught you to be really, really careful in terms of sometimes they'll get you to work this out by giving you the wasted energy. So remember, this will sometimes come in useful in that total input equals useful output plus any wasted energy, just in case they try to catch you out. So the kettle's got an efficiency of 91%. I also said to you, don't use the percentage. I mean, you can if your maths is fabulous, but just change that to 0.91 and use that in any calculations. Otherwise, you've got to deal with rearranging equations with 100 as an additional number to deal with. Tells us thermal energy, so now we're away. So the total input equals the useful output. We're wanting to work out. That is the useful output divided by the efficiency. You can see that I've just used the decimal there. Put it all together and you get that number there. 360,000 joules, or 3.6 times 10 to the 5 would have been accepted. Next one, useful question to be good at. So we've got energy resources. Global demand for electricity is increasing. So we've got a rising population, increase in energy demand for businesses or for humans. Think of the devices you have compared to what I had as a kid, as a young lad. You know, I had just coal to play with. So there is a debate about whether nuclear power generation should or should not contribute. Give the arguments for using nuclear power, and then obviously we've got to give the arguments against it. So to go through, arguments for, fossil fuels are running out, so we need to be able to replace their use. Now, ultimately, nuclear power requires ores, but the time for that to run out is in many thousands of years. Fossil fuels, and always get this answer in there, fossil fuels produce carbon dioxide, and this leads to global warming. Do not say fossil fuels produce pollution. Okay, it's really important. And we've got to give the argument, nuclear power does not. So there's quite a lot to get right in that sentence. Nuclear power is reliable, unlike solar, wind, or energy. So thus having it as a good idea in our energy mix. Now we're going for the against. And it baffles me that students leave this blank sometimes on a 6-marker. Everyone knows that nuclear power plants make nuclear waste. So, well, they're expensive to build and decommission. You know, they've been contaminated at the end of their life. There's a risk of nuclear meltdown and fallout. That's, you know, remember Fukushima in Japan. They produce nuclear waste, and add to it that this lasts a long time and it's really difficult to dispose of. If someone said, I've got some nuclear waste, can I bury it in your back garden? I'd be a bit upset. And the last part, it also, the nuclear power plant itself does have an increased risk of terrorist attack because any terrorist would know the damage that could cause to the UK. And that's that question done. Please stop.